wanted to start off with how much it means to me to be here today. I had the opportunity to speak at the senior living community of my own grandfather. I guess I should put the date on this. It was 2018, and talk about my time working on the Mars rover. And so it means a lot to me every single time I get to do this and share with people who bring now this moon joy, watching us be part of our generation. But also, I love the chance to get to talk and hear experiences from people who were part of going to the moon before. And so it just means a lot to, from every proud grandchild to be able to share what they do. It means a lot. So thank you all for having me tonight. Um, and so, to just start off, I'm a planetary scientist and I study the geology of the Earth, Moon, and Mars. And so that's really what my job is. And so, as a planetary scientist, I ask a lot of questions about other worlds in our solar system. And so, this picture is really neat because it actually shows every place that we have sent a human made object before. And have a picture of it. And so, we have pictures from comets and asteroids, of course, the moon, Venus when they had their landers go, the Venera landers that survived on Russian landers that survived on Venus for a little over an hour. Of course, Mars, Titan, one of the moons of Saturn, and our beautiful Earth, the only place we have found that gorgeous standing blue water. But what planetary scientists can do is a range of things. They can do geologic field work, really getting down in the rocks like I do. They can investigate planetary atmospheres, also the surface, or what's going on below the surface, as well as analyze satellite images and data. We've thankfully have a wonderful history of spacecraft that have been exploring our solar system, and they collect all different types of data. So we can send that back and we study it. And then the last thing, which we're going to talk a lot about today, which is one of my favorite parts of the job, is how we design and operate planetary instruments as well as missions. And so if you were able to watch any of the Artemis II mission, you might have seen pictures of people working in mission control. I was one of them. And so if you were looking at mission control and you saw all of these happy scientists, and this one scientist who is standing up, walking around all over the place, and you're like, how in the world did you end up there? Well, I'll tell you about it. I'm actually usually I live in Maryland, Washington D.C. But actually I'm here at Johnson Space Center this week because I've been working in the Mission Control Center because now it's time that we start getting ready for the next Artemis mission. This is actually a picture of where I am this week and where I've been all day. And so how did I end up here? I grew up in Hermitage, Pennsylvania, in a small town and have really been that kid who's loved space since the beginning. You know, here's myself getting my first telescope from Pop when I was younger. Always the kid who wanted to study science. Grew up and that didn't change. So thankfully, my grandfather and my mom combined a lot of Christmas and birthday presents to send me off to space camp. And I was able to really decide, oh my goodness, space is the most amazing thing, and I want to be an astronaut. And so all of a sudden, my life became okay, well, not everyone becomes an astronaut, so I guess I should figure out the rest of my life in case that doesn't happen, but hopefully it will. And so I went to school at the Florida Institute of Technology, and that was just south of Kennedy Space Center. So you can see I got to see my first real launches, and this was still during the shuttle period. So I got to see a bunch of launches. And then I started getting NASA internships. And one that was really impactful for me was working on the Curiosity rover team. So I was there and for when it landed in 2012, and then worked on it. Worked as a member of the camera team on that mission for about 9 years before I transitioned to what I'm doing now. I've gotten the chance to meet a lot of the fantastic leaders from the Apollo era. So I have a couple of them here. We have Rusty Schweikert, who flew on Apollo 9, Walt Cunningham, who's one of my favorites, who flew on Apollo 7, and of course Fred Hayes, who was on Apollo 13. And so because my first internship and job was working with Apollo data that was left on the surface of the moon, I really got to integrate and learn so much more about that history and get to meet the people who made it possible. I got my PhD from Purdue University. They call it the Cradle of Astronauts, the place where the first and the last man to walk on the moon has come from. And when I started there, I really hoped, and I always think maybe the first woman would be me. It's probably not going to be, but it would have been great. And then, so what I do a lot of now is I think about how imagery is related to how we do science. How do you, instead of taking it's almost like, with our phones these days, you can take an endless amount of pictures, but not a lot of them are good. But when you're on the surface of another planetary body, it takes a lot of data and a lot of time to take all of those pictures. And so I want to maximize science from the pictures and pull out different details about what minerals are in here, what textures do it, and thinking about these dynamic lighting environments and dynamic landscapes that we could image when we go there. And so there's a picture of me in Hawaii on a recently erupted volcano. And then this other picture at the bottom is a really neat one. It's from the Cinder Lake Crater Field in Flagstaff. And so this is a place where the Apollo astronauts trained. They learned how to drive around, and they thought, well, the astronauts need to learn how to drive around a bunch of craters. And they didn't have a place on Earth that just had a whole bunch of craters near them. And so what the combination of the USGS and the Forest Service did was they figured out how much TNT you would need to put in a spot to exactly replicate what it looked like on the surface of the moon in one place, and they exploded a whole bunch of craters. But that's a place that we can still go to now, so you can see me taking images and light that's similar to the lighting we'll see at the South Pole of the moon with the crater in the background. And so all of that experience from my history in lunar science, my PhD was in lunar volcanology, to also working on these experiences with other spacecraft, my specialty in imaging, it really ended up bringing me right to Artemis II. And so when they were looking for members of the science team, that expertise came through, and they asked me to join the team. And so the goal of Artemis II it was the first crewed test flight to the moon since Apollo. And so this was our first time that we were going to put humans on this spacecraft. And so we had a successful Artemis I mission, which didn't have a crew in it. They had gone around the moon multiple times, but now we are putting our friends on board. And so the way it launched on April 1st, we'll get into it, go around the Earth. And once we realized that the safety systems and the crew was doing well in the vehicle, everything was responding well, we did what was called a translunar injection burn. So we hit those, we lit up the engines again and sent ourselves on a trajectory around the moon. And so once we did that, we made our way around. We had a great observation period. We'll talk about around the lunar far side, and then we came back and our friends safely landed off the coast of San Diego. And so all of this actually went according to plan. And so this diagram on the right-hand side was, in the future, we're going to have to learn how to dock with more spacecraft, potentially landers that will take us down to the surface of the moon. And so they did a lot of practice piloting. Actually, every single crew member did some piloting on this to really test the maneuverability of the vehicle to help us prepare for the next stage. And so on Artemis II, even though always the objectives are first, make sure the crew is safe, make sure the vehicle's safe, and then we get to start doing our mission objectives. And so one of our mission objectives for Artemis II was actually to get the chance to do some lunar science. And so we did that with a few different methodologies. We had some handheld Nikon cameras. What was really important to us is we needed to have some verbal descriptions because, sometimes your pictures are good, but if you don't have those descriptions to match the picture, you don't even understand what the picture is of. And so we wanted to capture their verbal descriptions. Again, you can't always convey it through verbal or taking a picture. Sometimes you're like, let me just draw it for you. Let me show you exactly what I'm looking at. And so we had some crew drawings on their tablets. And then even though we took pictures from inside the vehicle, it is also really important for us to have the perspective of taking images from outside the vehicle as well. So we had these cameras at the very end of our solar array wings. So these solar panels that you see. And so they took pictures from outside the cabin. And then up in the right, you see our fantastic crew. On the left, we have Jeremy Hansen. He's a Canadian Space Agency astronaut, our mission specialist too. Then we had Victor Glover, our pilot. It was actually Jeremy's first space flight, even though he had become an astronaut, I believe, in 2009. And then Victor had been to the International Space Station before. The commander, Reid Wiseman, he had also had multiple trips to the space station. And then our other mission specialist, Christina Koch, she actually holds the record for the woman with the longest amount of time in space. She actually had lived on the space station for over 11 months. And so she has a lot of experience as well. So that was our crew. And we really feel as though they're an extension of our science team and really fantastic humans that I got to share. I'm really excited you got to hear from their journey. Nope, I went too far. So I'm not going to go into all of these. Don't worry about it. So with Artemis 2, we had a lot of science to look for. And so the way we chose what science we would investigate is we wanted to take advantage of the unique perspective that we would have. Like we know that we weren't going down to the surface, and so we won't be able to see things that are very small on the surface. But there's a lot that you can learn from the unique perspective of where we were above the surface. We were about 4,000 miles away compared to about 60 with Apollo. So we were actually not just limited to what was directly below us. We could look at the entire lunar disk at once. And that's really important when you want to make comparative changes. Say, oh, the color over there looks a little different than the color over here. And seeing how that illumination changes throughout the course of our flyby. That's what we call photometric changes. Just like how your lawn or the buildings look a little bit different at noon during the day than you pick up more details when it's sunset. We got the chance to see all of those in one quick swoop. And we were looking at the history of the impacts, the history of tectonics, so the changing of the size and the surface. There's a lot of volcanic history on the moon. Every time you look up and you see those dark patches, those are giant ancient lava flows. And one of the things, those impacts are still happening. We have an atmosphere that protects us from so many of the impacts, the small meteorite impacts. We still see some get through, but the moon doesn't have that protective atmosphere. So we know that it is constantly being bombarded with things from space. And so we are looking for those impact flashes. And the last, but definitely one of the most important, we always want to look back at our Earth. Our Earth is beautiful, and every time we get a new perspective on it, we learn something more about our own planet. And so besides science, I guess I did go through this slide. Besides science, we also had a lot of operational themes we wanted to test. Because this was our first time in the Artemis program, we wanted to test how the crew were trained, how we actually supported them as a science team during the mission, how we developed products that the astronauts used during the mission. And now that we have all of this data, how do we preserve it so humanity can continue to use it and it will be available to the public? And so during the Apollo program, there were actually parts of the moon that were never seen with human eyes. And that was for a very good reason. And that's because we were going to land our crews on the near side of the moon where it was well lit. And all of them were sort of in those equatorial regions. And so every time that we went to the moon in the 60s and 70s, the near side of the moon was illuminated. And so we never saw the far side of the moon totally illuminated with human eyes. Yes, we have pictures of it, but human eyes are really powerful. Um, and so all of this figure shows all the lighter portions had been viewed during Apollo, and you can see sort of that triangle, that pieces that come up. That's because of Apollo 13, where they had to take a trajectory very similar to the one that we took on Artemis II. So they were a bit further away, and so they got that larger scape. And so we haven't updated this figure yet. And so I did my really pathetic addition to it. I'm sure once my colleague Ernie Wright updates this, then I can remove my line. But we saw a lot more of the surface that hadn't been seen. So this yellow line covers about what we were able to see during Artemis II. And so I'll skip that one. I'll do it. So different observations that our crew makes can really help us. They are clues to us. We want to learn about the history of the moon. We want to know about the subtle details and also the composition of this surface. It is our nearest neighbor. And so all of these observations that our crews make, they really help us add little pieces into the complex puzzle that we already have from Apollo, from our orbital data that we've collected before, from our upcoming missions. This is just one more piece of the puzzle that we're really excited to tie in as context to other scientific data. And so as we are sending humans to go to the moon, we also knew that they were going to be doing science at the moon. And so we do this by helping prepare them for their flight through different types of training. And so you can see all of us here with the astronauts. And so we did a bit of classroom training. So where we went over these science objectives, just like I was telling you, we've also taken them out to the field. And so this is one of my colleagues, Cindy, with Christina out in Iceland, because it's important for them to understand what they're looking at on the surface so they can help better make those inferences when they're looking at it from above. And then we also need to get them ready with their hardware. And so here you can see on the right, Reid and Jeremy in the foreframe here. So they're taking pictures of an animation of the moon on the big screen to practice finding the places on the moon they want to describe, making those verbal observations, and taking pictures with them. And, we didn't get to see the crew all the time. They have so many things to learn. And so we actually would create homework for the crew also. And so they would get homework to help them remember their lunar geology because, every night you look up at the moon here, you see the same side. But so you're used to seeing what it looks like up there, but we never see the far side. So you actually have to really learn that geology because it's just not something that you've seen before. And so once we've taught them how this is going to work in the classroom, we actually take them into the mock-up. And so the mock-up is the same sort of size constraints of the vehicle they're going to be in. And so we want them to get a chance to be in that physically confining space, dealing with their camera, their tablets, all their cords, their headsets, and working to practice taking pictures of the moon. So here is me helping them get all set up with their cameras. And then we decide, let's just hang a giant balloon outside the spacecraft inside this facility. So we blew, it's about a 10-foot moon, and we put it at the distance that would be representative of that size as they would see it. And so they were able to get in there and practice this process, practice finding those details, getting into that configuration and taking pictures of this inflatable moon. And that's a really good learning experience because managing all of that at once is very difficult. And so now let's talk about our journey here. So and it obviously starts right here.
10, 9, 8, 7, RS-25
So
engines lit.
first.
4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
So this was a really
Good
exciting
roll
day.
pitch. Roger, roll pitch.
Houston now controlling the flight of Integrity on the Artemis II mission around the moon.
And so
Integrity, AMT high. AMT high.
On time passing 30 seconds into the flights. Integrity passes the alternate MECO. Target milestone. Mission Control Houston seeing good performance on the 4 main engines. Space Launch System core stage. Integrity, 3 miles in altitude. Traveling more than 1,200 miles per hour.
So this was a very exciting day. It was the first day of the launch window. You aren't sure if they're going to go or not. All of a sudden, the entire day, they keep getting closer and closer, and then all of a sudden they're in there and they actually lift off. So much of our science team was together during this moment. We weren't able to be at the launch because we had to be here in Mission Control to start working as soon as they launched. So there's me in the background. Very excited. It was just really neat to see that our friends were going to space, but then it was time to get to work. And so the first thing that the crew did for us was start to take these beautiful pictures of Earth, these absolutely stunning images. It's been a very long time since the Apollo program that humans have actually been far enough to take images like this of the entire moon as a disk. And so this picture came back, and it looks a lot like the blue marble picture at first. But it's actually a little bit different from that because this picture was actually taken at nighttime. And so that's why it looks a little fuzzier because they brighten the exposure on the cameras to capture that. And so you can tell it's nighttime by a couple of different things. You can see the green at the top and the bottom. Those are our aurora, actually. But you can also see the city lights around the edges of the land here. You can see some of the stars. And you actually see, a consistent amount of these smaller white dots right around the outside. Those are actually satellites. So if you flip through the pictures very quickly, you can actually see them moving. And that's something that didn't exist the last time we looked at the moon, at the Earth this way. And then this bright splotch in the middle, not this one that's obviously a reflection, but sort of the lighter, bigger splotch here, that's actually the light of the moon reflecting in the ocean. So this Earth right now is illuminated by moonshine. And so the moon was brightening it up for us and ended up with this really neat picture. And then we got to turn the spacecraft and see our first view of the moon. And the crew was really excited to be finally on our way. But once we decided we were on our way to the moon, we got through that translunar injection burn and we were on our way, then we knew what the moon was going to look like when we got there. We didn't know what the illumination would be until we had that successful burn to the moon. And so we had to start building our science plan. And we couldn't, even though we practiced building it so many times, we couldn't build it until they were on their way. And so we wanted the chance to show the crews. So they had different targets that they would look at and different prompts to talk about, different pictures to take, and different details to draw on. So they had all of this on their tablet. And so we worked together as a science team to build this, to fill it out. And then we had to work to get it uploaded to the spacecraft and onto their tablets during the mission. And then one of my favorite days, on their way to the moon, they got another chance to turn the spacecraft because you have to keep the spacecraft with the solar rays pointed towards the sun. So the moon isn't always out the window. But every once in a while, we got to turn the spacecraft, put the moon in the window to sort of test some processes. And this was a really neat one because this was the first time the crew started to realize they were seeing the far side. So that dark spot down here, this is the Oriental Basin. And the near far side transition sort of goes right through it. And so this is where that term moonjoy came from, was their excitement of seeing the far side of the moon right now. and they were giddy. And so this is a really special moment as I look back on the mission of hearing that excitement and then knowing we're going to have so many more observations. And so I will play this one. Let me go in a little bit here.
Good morning, Houston. Integrity on one. That was an awesome message from Jim Lovell, and very cool to hear him welcome us to the neighborhood. It's going to be a great day. Thank you.
Yeah, so every day they would get a message, and I have the wrong part of this clip. But before Jim Lovell died, he actually recorded a message for the Artemis II astronauts, and they played it, welcoming, as Reid said, welcoming them to the neighborhood of the moon. And so this was about to be their lunar flyby day. And so we go a little bit further.
And 12,712 miles from the moon. Let's actually savor the calm delay that we have. We're ready for the morning DPC.
Beautiful. We are savoring it down here. Good morning, Integrity, and good morning, Moon. Our room is buzzing with moon joy today, and I imagine yours is too.
We are ready to go. We are looking forward to working with and for the science team. And we are just excited to be so close to finally accomplishing what we've been training for so many years.
And so that message right there is very powerful to us. To hear them be really excited to do their lunar flyby for the science team and thanking all the training that they had gone into to prepare for this moment. And so it was really neat to hear that. And it came through. During the lunar flyby, we divided the crew into pairs. And so we had a crew at the window, and they were the ones with the cameras and taking those recordings. And then we had a pair that weren't at the windows. They were still making sure the vehicle was safe. But if you watched any of the broadcasts, you heard some of these science situational updates. And so they were the ones giving the updates to the world about what they saw out the window. And so you heard some amazing descriptions from them during that time. So you can see them here, Victor's face illuminated by the moon, Jeremy with his head in the camera trying to take some pictures. And these are some of the pictures they got, and they are gorgeous. And so you can see the dark near side mare here that we can see from, whenever you go outside. And there's a full moon. You can see this dark area, Aristarchus, and then you can see that giant Oriental basin. This is one of the textbook impact basins in the solar system, and it is something that we use around the solar system to learn about impact cratering. And so you can see how scarred that this surface is. And we're really excited to get a chance to look at it. Here's a closer up picture we got back of Aristarchus. This is a volcanic rich region, obviously like a billion years ago, but it has very explosive volcanism and a lot of volcanic glass. And so as they were describing some of the colors, the browns and the greens that they were seeing on the surface, a lot of that is because of that volcanic glass. And it was really neat to hear their descriptions describe something that I had been studying for a really long time. And so each of the astronauts got multiple turns up in the windows, making these observations. I've been listening to some of their recordings lately, and they are hilarious. They are excited. You can tell that they're just having so much fun, and yet the geology is just flowing so freely. You can tell they trained, they practiced, they want to do the best they could for the science team, and they really did. Some more of these beautiful close-up pictures to the point where you can see, like in Oriental here, you can see that there's different colors of that mare or lava material, meaning that different eruptions happened at different times. And that's really exciting. Or this bright, really new crater with how its light rays go all the way out. And so you can tell that's a much lighter, much younger crater. And then we started to get to the point where we had the Earth and the moon in the same frame, because we are getting around to the far side of the moon. And that meant that we're going to lose our contact with Earth. And so we started to see these pictures of the moon setting. And this is a really scary time in the mission because you actually lose that connection. You lose that vocal communications with the crew because we can't have those airwaves between the Earth and the spacecraft when the moon's in between. And so in mission control, they tell you, take a look at all your screens, memorize what you need to memorize right now, write down everything because we're going to lose contact with them and the crew are on their own. But in this moment, the crew took some time to talk about how beautiful the Earth was, how it was just this oasis in the distance, and how really the feeling that they had was love for our planet, for the people on that planet. And it felt very special to them to see everybody they know in one little swoop right there, this one little crescent of the Earth they could see, and they know that every human that they love is over there except for the 3 others around them. And so we got some of these beautiful Earth set shots that really remind us of those Earthrise shots we saw on Apollo 8 that Bill Anders took. And you can really see in this lighting how impacted the moon is. You can see all those craters and the history of its bombardment of things hitting it. And then this is a beautiful picture of what we call the terminator. It's that spot where the light meets the dark. And Victor described this as, the holes look so dark you could just jump right into them and disappear. And so that light meeting the darkness makes it look so rigid. And you're like, what? The rest of the moon, it looks so smooth. But actually, the entire moon looks like this. It's just the illumination playing with your perspective that the shadows really bring it out versus like light that's higher from above. And so using the terminator is actually how they first mapped the surface of the moon in the 1600s. Is every night they'd go and they'd draw what they saw right along the terminator with their telescopes. And that's how we got our first lunar maps. Some more beautiful pictures along the terminator, showing some of these craters with these central peaks and just these beautiful landscapes that we have. And then I'm almost done here. I got to our last part of the mission, which was a really unique opportunity. We would have only gotten this if we launched on April 1st or April 2nd. It wouldn't have happened if we launched in February or in March. We got the chance to see a solar eclipse during the flyby. And so what that means is that the sun is going to go behind the moon. And therefore there's going to be no illumination on the surface on the side that we're looking at. And that's a little bit scary because, we're in a solar powered vehicle. And so we had to learn a lot about that. But scientifically, that's really interesting. But health-wise, we shouldn't look at the sun. So we had to make sure that some safety eclipse glasses got on board. And these pictures came through. And so when the sun went behind the moon, all of a sudden you heard Victor say, "Holy cow, we've gone sci-fi." And I'm not sure what I thought in that moment. And he's like, "It looks like there's just a glowing orb around the whole moon." And I'm just standing there in the science room going, "What? What do you mean? That makes no sense. Like the video I have looks dark." Because really low frame rate, really poor camera from the vehicle, it couldn't do it. And then all of a sudden these images started coming down overnight. And so you can actually see the dust sort of following this diagonal here, and that's the dust that lives in our solar system called the zodiacal dust. You can actually see the corona of the sun here coming out, these streaks, and so that is the corona of our sun. You can see the topography of the moon right here against it. And then here you're like, well, it looks like part of the moon's illuminated. Like I thought you said the sun was behind the moon. That's illuminated by Earthshine. So our own Earth, just like how the moon was illuminating us in that first shot, we actually give our light back to the moon. And so that portion of the moon was illuminated by Earthshine. And so it was really an honor to be a part of this team. help be a leader on this team, to be a part of this mission of the return. And I know it's just the beginning as we start into the Artemis program. But we learned a lot, and I cannot wait to continue. And then, of course, the most important part of the mission was when our friends come home safe. That is always the goal of every single human spaceflight mission, is to bring our friends home. And so there's always that there's that huge sigh of relief, not a little bit, a huge sigh of relief of when we saw them touch down and we saw them start coming out, and saw them, to know that they're going to be back with their families, and they were back with their families the very next day. And so I'm sure that Stacy will send this around also, but there are some great activities if you want to talk about this with your friends and loved ones or anybody in your family. There's a lot of excellent activities on how to observe the moon like an astronaut. It's sort of built after the way that we train the astronauts. And so these all exist on NASA's website. Stacy helped put so many of these together, and I really encourage you, if you just want to have a fun day looking at the moon and talking about it, to look into this. And for my last slide, I just want to thank these 4 humans and all the entire team around it for taking us on this journey around the moon, and really spreading their moon joy to all of us. And I can take any questions.